Hi. By this time, I think probably you all read this slide, right? What is there? Right? It's mandatory. You have to read and you have to agree. Okay, just joking. But in a nutshell, right? To summarize you, it's a forward-looking view. Don't take any financial decision based on the presentation. What we're doing. I think it's clear now. Let's move to the next one. So let me introduce myself first. Krishna Somasundaram, architect in Shell, working in Advanced Analytics and all these platform onboarding projects.
And I'm Bryce Bartmann. I'm in the Data Science COE as a senior data engineer.
Right. What is the topic today? So how we scale advanced analytics into Shell. So a year and a half ago, we tried with Databricks. Before that, we tried with various other platforms as well. So the process we started running, initially it was running like 4 days, 5 days to run a model. And then with the Databricks, we reduced to 25 minutes. So it's a journey. I don't want to explain everything, but that's a significant impact we created, yeah, with using Databricks. So that's what we're going to talk about today. So based on that, so we recently Shell is going through a lot of digital changes. So one of the key theme for that is Shell digital strategy. What we're going to do is a coherent approach for Shell, all lines of business, Shell to realize and accelerate the value through digital. So which led by the business and our digital teams, supported by our digital teams. Now, Bryce.
All right, so in that digital strategy, one of the components that we have is the Data Science COE, and that's where I play a part. And it's actually a really exciting space for us to be in. And it's really good that Shell is investing money in this space. And I just want to talk to you a little bit about the things that we focus on and the tasks that we kind of work on every day. So the first one is we select foundational technologies. So Shell has given us the remit to innovate, to look at all of the latest products and look at what is best in class, as well as giving us the functionality that we need in the energy space to be able to achieve things in data science. So that's where Databricks and our team work closely together. I work in London with the Databricks team, where we have weekly meetings to discuss what we want next from Databricks, what we're working on. We have our solution architects that help us with our projects. It's really a close relationship, and we monitor that on a weekly basis. And Databricks is just one piece of the puzzle. We also work very closely with Microsoft, and we explore all of the technologies that come out with them. Microsoft Ignite was out last week, and we've already been on the phone to them multiple times about new products that are very interesting to us in the time series space. So that's one of the cool things that we get to do, and I'll be honest, that's one of the things I enjoy the most in Data Science COE is really exploring all the latest technologies and then being able to have the license to tell Shell that this is what we think is best for them. The next part is showcasing the art of the possible. So what do we do with all these technologies? We then start to look at use cases that we have at Shell. And you can think there are quite a few. We have upstream, so we manufacture. We have downstream, where we're actually selling all of our products. And there are so many spaces in there where data science is applicable. And so what we do is we take some of those ideas and we push them through our Data Science COE and explore how much value is in that data and how much can we contribute to Shell's bottom line. And the art of the possible is really where the headlines come out, and you talk about being able to deliver hundreds of millions or billions of dollars of savings if you apply the right algorithms and the right data science to the data that we have available to us. And that's a really exciting space for us. And then what we have to do as well is because we're forward looking as a team, we also need to think about how do we share all of this information with the rest of Shell. And so we build things like our analytics network, which is a Yammer group that has now 1,400, 1,500 people, I think. It's going so quickly, I think I'm actually behind the mark there. But that really helps us to get our message out. How do we work? What are the technologies that we're looking at? And what do we want to focus on next? And that is now, it's such a success that it is creating something called the Digitalisation Lab, and which Krishna is going to talk about in a little bit more detail later, and hopefully something that you can take away in your corporations to think about how you can get analytics tools into your business users' hands and your IT people's hands so that they know how to deliver analytics projects in the future.
Oh, you want the,
yes, so how do we do it? So this is our pipeline. We talk about it as a funnel. So on the left-hand side, you'll see that what we have is a space where the business can come to us and present ideas that they have. Some of them are really good and some of them are really terrible, and it's like our job to make sure that we can flush those out and really only focus on what's going to deliver value. Some people also have a warped perception of what is value, especially in a corporation the size of Shell. So some people think saving $10,000 a month is a massive saving. For us, that's not really the space we're playing in. We're really after some big numbers. So we need to entertain all of those ideas, but we also need to filter them out. And that's where we have a team that work on that, and then once they've decided on something that has real potential, we then start to funnel that into our team, the Digital Science COE, and the digitalization space, really depending on the kind of skill sets that are needed to deliver the product. So we take that and we build agile teams. Normally, like we talk about it, like Amazon do, so a team that only needs 2 pizza boxes to be able to feed the whole team. So we really want small teams that can deliver at scale. And this is quite interesting because it's quite a big shift from where Shell has operated in the past. If you think about some of the landscapes that we have, where we've done waterfall in massive scale, spanning multiple years to deliver billion-dollar IT projects. This is really a big change for us. And so the Digitalisation COE is the leaders in that in Shell. So we take ideas and then we put teams together, and you heard Dan mention earlier something called an accelerator. That's a really good way of us building teams where we can clear the way from all the bureaucracy that happens in normal IT projects, and deliver an MVP in a short space of time. We're talking about 4 to 6 months in that space. And then as the digitalization COE starts to ramp down, as you can see in the top, with our interaction, and then as it goes through multiple releases to get to production, we start to include IT more and more during that process to then start taking over that product and to own it so that they can support it on a global scale. And that's one of the interesting things that we've had to tackle, because if you think about it, we have very smart people, most of them with PhDs, delivering and working out how to solve problems in data. But what the interesting thing is, once you've got a good idea, how do you deliver it at a global scale? Because at Shell, you can go from a few people working on a product to suddenly having to deliver across the globe. That is not a small thing to overcome. And so that's where Databricks really came into the space for us and helped us to deliver some of our critical products and digital products that we are working on and have worked on. And so through all of this, we just want to be clear that the business are driving this whole digitalization space. They are the owners of these products, and we think that that's critical to making sure that ownership exists in the right places. So with that, we want to talk about also how the Digitalisation Lab is being used to enhance or increase our space in the analytics space.
Thanks, Bryce. So now we talk about the Digitalisation Lab. As Dan mentioned in the keynote this morning, nearly 500 users across Shell is leveraging. What is this lab? It's like a sandbox environment where you do this proof of technology, proof of concept, and proof of value. All the ideas, in the previous slide Bryce explained, all the ideas comes through, they play with in the Digitalisation Lab. So we have all the different technologies, like from Alteryx, Mana, SAS, and MATLAB, and our Studio, our Shiny, along with Databricks. So they play with the use cases, and then if it provides the value, then they will push it into a production pipeline. So before that, they have the license to operate within this. They have we operate in a user-based model. Once they have the user have the access to the lab, they can use any tool, try to come out the value of their proposition. So that's where the lab is mainly used for. And more and more users within Shell, they want to use the lab, and mainly one team supports all the products. That's the interesting piece. And now I'm going to talk about how we operationalize the Databricks within Shell. So we have 4 different environments. One is the lab, which I've explained the previous one, and the next 3 is we have a development, acceptance, and production. So the lab is completely licensed to operate for the POC, POTs, and POVs. So once that moves into the phase as a production pipeline, right, is a project is created and properly governance is placed in the dev, acceptance, and production. So we follow the IT process from the dev onwards. I think the lab gives the agility and the the dev till production gives the control of the data. So that's how we operate within Shell for all our tool sets and technologies and the platforms. Now Bryce want to make to the next one. So in this one we have a 2 use case to share about. One is in inventory optimization and the other one is machine vision. Bryce.
Okay, so what I was talking about earlier was we were a really small team when we started. I think all of us that are in this space have all started as small teams in corporations, because I think a little while ago, corporations weren't too sure about data science and really what value it could add. And I think listening to some of the stories at the customer advisory board yesterday, there are a lot of people on the same journey. And I would hope that some of these slides today can help you if you are moving into this space and and you're thinking about how do you scale some of your ideas. So obviously in data science COE there were some very obvious things we could do really quickly to deliver value to Shell. And inventory and our massive SAP systems that we have running in upstream and downstream really hold a lot of information, and the beauty about those systems is that they're old enough for machine learning to be used effectively. And so what we had to do was take a small idea, which was to predict how much inventory should we hold on stock in all of our warehouses across the world. Now that doesn't sound like a very difficult thing to do, but when you think about the scale at which we have to deliver it, suddenly the numbers stack up very quickly. And this project in particular put us on the map, because we were able to, I guess, market ourselves under a successful project and using large numbers to back up some of our claims. And so what the inventory optimization project is all about is looking at how maintenance is running on pieces of equipment and how they've run in the past, to predict how much we should actually be holding in our warehouses to basically optimize maintenance, so that we at least don't overexpose ourselves and not hold enough stock, so that if something went down it would cost us a lot of money, but also not holding expensive parts that maybe we only change 1 or 2 times a year, and not having like 10 or 15 on them in stock that are big numbers. And so this whole solution was built in R originally, in R Studio, because as you can imagine, data scientists are very academic and very capable in those tools. But what we then landed up having to do was take an R product and deliver it at scale. And Krishna is going to take you through how we did that.
Right, the architecture, so where the data sits within our on-premise, the Databricks operates in the cloud. So that's a challenge we were facing, and we need to push the data into the cloud for processing. So our data sits within SAP HANA Cloud Platform within on-premise. So we used Alteryx to push the data into the AWS S3 bucket, and then where the Databricks can access the data to process it and writes back into S3 bucket. So, and then there's a lot of challenges in between. I think stage by stage we resolve those challenges, and the data write backs into our SAP HANA. This is a kind of architecture. It looks very simple, but operationalizing it adds its own challenges in terms of scheduling, and those things are initial teething issues, and we come across. That's the way we architect the inventory optimization. So the next use case, do you want to?
So I just before we move on, I just want to cover where did we deploy this. We had to deploy this initially in the Gulf of Mexico, but then downstream started to really like the idea of it, and we've had to scale it across the world. So this is one of the first products that we delivered at scale across Shell from our team. All right, so the next use case is something that we're really excited about. If you follow some of the latest products, you probably heard a bit about our machine vision team. We have some here today. And this is something that is pushing the boundaries for everything we do in Shell. So when you think about machine vision, it's the latest technologies. And when you think of Shell, it's a massive corporation that doesn't like change rapidly. But we challenge that because we need the latest technologies, and we need them all to be deployed yesterday, basically. And so the problem is we've had this is for IT and our team to work together to make sure that we can deliver this. And the results are staggering when you see it. The engagement that we have, so when we have people come into our space in Canary Wharf to look at what we do, this is one of the things that has the biggest impact on people that see what is achievable when you put the right skills in place and have Shell invest in those people. So machine vision has a number of use cases. We're only going to talk about a few. Like I said, if you've seen this, what we've talked about over the last couple of weeks in the public space, you'll know that we have multiple uses for it, but the ones I want to talk about that are interesting for us today are around how we can use this for inventory counting and pipe counting. So what we are doing is training models to be able to analyze inventory and then do the counting for us. So the way we do that is just by training models in TensorFlow and then being able to deploy them onto multiple scenarios where it can count the inventory for us. This is producing really good results, but it also starts to show what is possible. So we now know that if we build models like this, what else can we do? And so we're starting to look at how we can use robotics and things like drones, where Shell are investing in drone companies, to be able to use this technology that we're building and deploy it at scale. How does this fit into what we're talking about today? Well, Databricks, again, is our compute engine that is going to be supporting all of this. And where we've worked really closely with Azure and Databricks to get GPUs enabled in Azure so that we can use these technologies. The next bit that I want to talk about is something that's really interesting. You might be curious because you've probably all been on a Shell forecourt filling up your car with petrol, and you might be interested in what we're doing there. So this is a very interesting space for us. As you probably are aware, safety is Shell's #1 concern above all else, financial included. And what we are targeting machine vision for is more safety on the forecourts. Some things that you may have seen are like we are detecting smoking on forecourts, but we also want to take it further than that, and all behaviors on the forecourts. We can notify the right people at the forecourt that there is behavior happening that we can't entertain. And so some of it is also looking at the way cars are driving on those forecourts, whether they're going the wrong way, whether people are at risk, etc. And so I'll show you a very quick demo of some of the footage that we have used for our proof of concept, while Krishna tells us how we architected this.
Right. So this is one of our retail station, which is a remote location, and this architecture fits in for our all the IoT use cases. So where we train a model and deploy into our edge node to capture these activities, and then does the video analytics and processing it, and sends back the response to the cloud, where the Databricks is process those model and train the model and then redeploy into the edge node. This is the cycle with the continuous integration and deployment we are adopting there within Shell. So this use case, this architecture fits in with all the other use cases as well, IoT use cases.
Yeah. And so I think what's important here is to just talk about that relationship that we have with Azure. So Shell's strategically chosen Azure as our cloud platform, and we work with a number of people in Databricks and Azure to get the products that we need to produce or deliver products like you're seeing on screen. And that's been a real success for us, be able to have links right into the cores of those corporations to be able to make changes and deliver products like you're seeing here today. Okay, so we're going to spend a few minutes talking about where next with machine vision. So like I said, Shell has obviously got a robotics arm to it. It's not only in the digitalization space that Shell has been investing in robotics, because you can think of all of deep water exploration requires robotics, and so we have a big team that does it, so it's a natural space for us to move into. And what we are now looking at are what else can we do with machine vision. So one of them is tracking inventory or tracking assets in the field. So it would sound strange, but we have a lot of assets that are tagged but not necessarily have all the information about them. That is a laborious task that is done normally manually. With machine vision and the possibility of robotics and drones, we think that we can go and do this task more productively. The other ones that we're looking at are leak detection. We've also done some really cool POCs on on moving parts, so you may not be able to track whether a piece of equipment is going to fail from, let's say, corrosion if you just watch it as a person, but if you watch it over time and then speed up that footage, you can actually start to track that there are problems with that equipment. And so we're going to be using that in those spaces. We're also going to use it for abnormal heat signatures, site security, corrosion detection, and plume detection. Okay.
This architecture plays across all the IoT use cases like drones or any device, remote device you take. That's the way we are planning to approach. So I think that leaves us to the next interesting chapter, which is Q&A. I think we explained pretty clear, I believe. If you have any questions, please.
Yeah.
It's a question more about drones. How much do you have to spend to get an effective drone?
You got this one up.
Yeah, so how cost effective is the use of drones, and how much do you have to spend to get an effective drone to kind of survey what's the kind of improvement over doing it manually?
That's a very good question, right? So as we always say, for Shell, safety is important, right? Our assets is on-site, onshore, offshore, in all of the locations, as you know. So whether manual, there's a lengthy pipelines is going across, right? So going manually and visualizing any for corrosion will be a tedious job. So that's where we use drone in that space, or any kind of a pipeline, wherever offshore or onshore, we use that drone. So in terms of how cost effective, let's get into that bit later, but the main thing is the safety. So the safety is our concern, the first priority, and the drone helps us, our safety. That's the way we want to play, actually. The cost is there, but we are giving much more importance to our safety.
Hi, thanks. Enjoyed the talk. You highlighted a couple of things, particularly the slide where you were saying about from the ideas through to production.
Yep.
Just wondered if you could articulate. I'm sure you've got plenty of, things where you've had stresses and challenges on there, but could you highlight a couple of the key ones? I mean, especially from, say going from scale, so getting your first one going through there wouldn't have been too bad, but as soon as they see it's something useful, what are some of the challenges of what happened next?
Okay, so I think the biggest challenge, I think I touched on it just briefly, was the normal way that we deploy products, IT products at Shell, is a challenge because you've got to incorporate so many things. Our information risk management is what we take is the most highest priority. So we cannot produce products that are sitting in the cloud that people can access and get information about Shell. So when we do POCs, it's really easy for us. That is not a concern. So we can come up with ideas really easily. What we then the thing that we ran straight into was, once we thought we would go around, so we can do this proof of concept, we can deliver something in a couple of weeks and prove that it works. But then when we tried to go and say, okay, well now we're going to go and deploy this, all of that, the other components about producing a quality product came at us, and we didn't really know how to solve that. And so some of it is obviously around quality, and we've had to address the ways of working. So we used to work in Agile, and now we're much more focused on DevOps, so that we can make sure that we do things like unit testing, and we can control our deployments, and be able to notify users of new things. But the other bit that was really interesting was some of the noise that you get with producing a product in production phase is unnecessary. And so that's why the executive committee invested a lot of money in building these accelerators that we talked about, which cleared the path for some of the stuff that we kind of got tripped up continuously. And that was to show if we give these teams the ability to deliver a product and clear all of the kind of things they normally would have to deal with, but still quality and safety around data was implemented, whether they could still do it in 4 to 6 months. And that's been a really big success for us. So that's kind of what the MVP part of what you see on that slide is. That's how we got to that point of the pipeline. The next bits that are what we also really struggling with and why we moved to DevOps was we had to think about, we were building these products and then owning them. And we're not a team designed to be like that. Like I said, we were a small team when we started. We are much bigger now, but we don't envisage or we don't see that we would own this going forward. And so we needed to really think about how do we hand these products over to IT, where these are some very complicated solutions, and that we needed them to be on the journey from the start to understand how to own it once we go into production. And so that's been a big step for us where we get them involved at a much earlier stage.
Let me add to that. The controls and those are the main things. So how we move from a waterfall to a agile to a DevOps. That's a big journey across the industries having, as well as Shell as well. So we try to have a robust architecture before we start developing. I think that's a mindset we used to have, and we slightly changed. Okay, in an agile way, we build the architecture as well. We know the end goal, and we build step by step to help the digital team to accelerate. At the same time, having the IT vision, okay, where we want to be with the controls step by step in place. So that gives the agility. That's a lesson we learned in going through that journey. So now we are fully equipped. I wouldn't say fully. We are we are getting closer, right, in a way to operate. Yes.
I hope that answers your question.
Some way, I'll catch you up and speak.
Thanks, that was really interesting. One just quick thing I was a bit confused by, organisationally, so the Data Science COE, is that part of the Digitalisation Lab or are they independent but overlap?
Right, the way our Shell is designed at the moment, it sits in the technology tower. Right. IT sits in a different tower. It sits in the technology tower, Data Science COE. Yeah. So because in Shell we have various technologies, but digitalization is one of the pillar within the technology.
So we've just recently formalized into a digitalization COE, which kind of oversees everything in digitalization. And then data science COE is a component of that, and within inside that is the Digitalisation Lab.
Right, okay.
But still operated by IT, but the owner is the digitalization.
Okay, anything else?
We might get time for both of these.
Okay, we'll go quickly.
Hey, thanks for a very interesting talk. Following on from these questions, I wondered if you could say a little bit more about the team composition. You said that you kept it pretty small, you could share from a couple of pizza boxes, but in addition to data scientists and engineers, what kind of skill sets are involved at that stage?
We have a various skill set, from visualization till the database as well. Like if you look at, we have a visualization and the data engineer, data scientist, and a developer if you want to build any of the microservices. I think all these capability, initially we started with that, but now data engineers picking up, expanding their remit to API development, and still niche is for the UI we given to the specialist. So that is the range we are seeing now. Yep. I think going forward, the one of the digital strategies is building our capabilities in-house, so that expands within each one's role as well.
Yeah.
What is the failure rate at this digital stage? So meaning sometimes the digitalization doesn't make sense and manual work is more efficient, or whatever, cost-wise, or so. What is this failure rate at this stage?
Do you know the failure rate of
We don't know the failure rate, but the mantra we've been given is fail fast. That's the reason. Okay, if you see the left-hand side, right, it's the iteration in a shorter cycle. Right? Do something, do it in a week's time or couple of weeks. Okay, is it going to make it what? investing time and money in that, right? So that's where we say fail fast. And I think the success rate, I think it's less at the moment, and because we're trying all the ideas in that initial funnel. Yeah, so that's where from that phase success rate is less. But if you look at the later down the line, the success rate is getting higher because we funnel through the first level or filter through the first level.
Yeah, and we don't bruise as many opinions if you can fail just at the idea phase rather than at the delivery phase. Yeah.
Allied, we've got one last one.
Okay.
So Krishna and Bryce, do you have any challenges when you deliver the digital MVP or data science project, and then how IT is going to support that?
Yeah.
Right.
How did you all
So that's why I think I answered the question, right? If you look at where the digital COE starts, the IT starts there, right? So the digital COE ramp up quickly, but still the IT in terms of designing and all these things is there, okay? How this solution is going to be productionized and supported. So still there is if you look at that IT area, still it goes as well. Well, initially it's a bit challenging, but when we put the journey together, right? It's not that much of an issue. But it's basically the support team onboarded in the journey of the development as well. Does that answer your question?
You've got a nod. Ladies and gentlemen, thank you very much. Big hand for Bryce and Krishna. Thank you.